Okay, so I'm going to talk to you about something that we're going to be working on for the programmable electronics. And so the platform we're going to be using is Arduino, as we mentioned before. And the way that we get to the place where you can program it is right here. And so as you're watching the video, I'm actually going to encourage you to go here. And you don't have to do anything except to sign in, so make an account. Okay, so you can sign up here. And whatever sign in you use, make sure you remember your login, that you don't forget it, okay, because you're going to be using it. Alright, once you log in, you're going to click right here to get to the online editor, okay, which is going to load this platform called Arduino Create. Now when you load it, yours is going to look a little bit different than mine. I recommend going to the preferences setting. You can change the theme, so this is the theme that it starts with, the light theme, which is good, but I think the dark theme a little bit easier on the eyes and also looks cooler. And then I also recommend clicking this checkbox here that says enable autosave. So what this allows you to do is kind of like when you're using a Google Doc where it keeps saving it automatically. You want to click that. You also have an option to change the size of the font in the editor here. You can go as small as 1. I have mine at 20 for the sake of the videos so that you can see it a little bit better. Okay, and then there's this area over here, if you look to the side, where you can see the sketchbook. So these are programs. You click on that. This is all the programs that you might have written. You can see I have a lot because I've been using this to teach with for a couple of years now. There's a place where you could find examples, and this is where we're going to start. Okay, we're going to start with example sketches. Okay, so go to the examples section and click on basics. Okay, in the basics we see these 5 sketches or 6 sketches here. The one that we want is the blink sketch. Okay, and so we brought up the blink sketch right here, and if we set this to full screen, what we can see is a description of what it does. Okay, let me move the screen back over here. Okay, and so what it does is it turns on an LED for 1 second and then off for 1 second repeatedly. And what this means is when this is basically a chunk of code that you can take and send to the Arduino, the board itself, so the computer will take this code, send it through the USB cable, write it onto the Arduino, and then the Arduino will use this code to control a light. And so what that means is you're going to have a light that flashes on and off because the Arduino is telling it to flash on and off. And you could see here that this line of code right here and this line of code right here are what controls how fast it's blinking on and off. So this 1000 represents the number of milliseconds. So 1000 milliseconds is 1 second. So we turn the light on, we wait a second, we turn it off, we wait a second. And then the way the structure of the code works is that this piece right here is called the loop, as you can see right there. And so when you start up the Arduino, if there's any code up here, it's going to run this code. Then it's going to run the setup function. And so the setup function runs 1 time. And then this loop function is going to run over and over and over again until basically you shut off the Arduino. So it goes on forever. Okay? And so these are kind of the basic tools that we have. We can do things 1 time, or we can do things forever. Okay? And so we're going to kind of talk about this and some of the other things you might notice. So one thing you'll notice is that some lines are tabbed over. Okay? When things are tabbed over like that, it means it belongs to inside of these braces here. So there's an opening brace and a closing brace that represents this loop function. Whenever we open a brace like this, we have to close it somewhere to show where this loop function ends. You'll see a similar thing here with the setup function. You have a starting brace and an ending brace. Anything inside here is tabbed over. Okay, something else you might notice is that some lines end with semicolons. Okay, when we write a line of code, we have to put a semicolon at the end of it so that the Arduino knows that's the end of that line of code, and it should move on to the next line. And then you'll also notice that some of the words are colored and some of them are gray. The gray words are comments. And so you might remember from Python that we use the pound sign to make a comment. In Arduino, to make a comment, we use the two slashes, and then whatever you say right here doesn't affect the code. Okay, so as we continue, I want to talk about what these little spots are on the Arduino. You see these little openings with numbers next to them? These are pins on the Arduino. Okay, and a pin is basically a way that it can interact with electronics that are outside of it. And it's kind of like an electric switch or a digital switch. What that means is we use physical switches when we were making when we made our circuits like this. And so what happens here is this is, instead of a physical switch that you can switch on and off, it's a digital switch, and the brain on the Arduino tells it to turn on and off. And so when we do so, what we do is we have all these pins, so we have to reference a pin. Let's say that we're going to use pin 10. So we have to reference pin 10, and we have to tell it to turn off when we want it to turn, or sorry, tell it to turn on when we want it to turn on, and we want to tell it to turn off when we want it to turn off. Okay, so when we go back to here, we're going to go ahead and modify this code so that we can use pin 10 as a switch. And so the way that we do this is where we have the setup here. We're going to go ahead and where it says pin mode, we're going to tell it to choose pin 10 and assign it to an output. Okay, pin 10 can be, any of these pins can be inputs or outputs. We'll talk about what it means to be an input later, but for now we'll just use them as outputs. And so we're going to take pin 10 and turn it to high. Then we're going to take pin 10 and turn it to low to switch it back off. Okay, and so we're turning 10 on and off and on and off repeatedly every second. And so what's going to happen is, let's say that there was an LED connected to this. It would turn on for a second, then it would turn off for a second, and then on for a second, then off for a second, and repeat. Okay? Well, one thing that might be helpful is maybe we want to switch the number of the pins. So maybe instead of connecting to pin 10, we want to move it to, say, pin 11 or pin 8. And if we want to do that, well, that means we have to go through and change 10 here, and change 10 here, and change 10 here. So one thing that can be helpful is we can create a variable. Okay, so a variable, like in algebra, is a term that can store information. It can represent a variety of things, and we can store some information in it. And so when we create a variable, we have to say what kind of number it is or value it is. And so generally we're going to use an integer, and that's what the int there stands for. And so the first variable we'll create, this will be for the LED, so we'll just call it maybe LED pin like this. And so what's going to happen is we'll say this is equal to 8, so if we want to put on pin 8, or we could change it to pin 10 if we want it on 10. However we want to do that, we can change it. And so what we'll do here, we'll say this is LED pin. So that means that whatever value is stored here is going to go here. So this is going to take pin 11 and set it as an output. And then LED pin. So this is going to take pin 11 and turn it to high, and then pin 11 and turn it to low. And the thing that's useful about this, that value here is storing the 11. We can change it to an 8 if we want and move it to the 8. We can change it to a 5 if we want and move it to the 5. We can change that value here, and that change will carry over to both here and to here. Okay? So the last thing before we wrap it up, if we wanted to make an LED blink, these are all the things that we need in our code. We need in our setup or our startup loop here to set the pin mode as an output. If we were adding another LED to make 2 blink, we would add a second pin mode, okay, for that LED. Then we would need to tell that particular LED to turn on, so write it to high, and then we do it again to low. And if we put one right here and one right here, so like let's say you had one on pin 8 and you were going to turn it on here and off here, so turn, sorry I can't spell, turn other LED off, turn other LED on. So they would blink together here basically, or you could switch it so that one is on and one is off at the same time, and they switch back and forth, and you can kind of have some fun with it. Okay, and I know that this is a lot of information all at once and it's probably really confusing, but the more we have time to experience it, the easier it's going to get. I also want to point something else out. If you leave something off, like the semicolon, then it's okay. If you try to run it, it won't let you, okay? And so it says error compiling. I didn't even get the error yet. When we write to the board, we have to choose the board. And so we're using Arduino Uno. We scroll down here, find Arduino Uno, or it says here Arduino / Genuino Uno. It's way down at the bottom, okay? And then if I click verify, you're going to see there's issues that came up. There's too few arguments in this function, so I'm just going to delete that function for now because we don't need it. Let's say I forgot the semicolon there. If I click verify, it says expects a semicolon before the closing brace. And so there's an error because something went wrong, and so it's not smart enough to know there should be a semicolon right here, so I have to go back and add one, and now it's good. Okay, and so often you're going to get the little red screen here that pop up at the bottom that tells you something's wrong, and that's okay. Part of the process of coding is trying to figure out what went wrong and fixing it. Okay, half the job, or let's say 25% of the job is putting the code in, the other 75% is getting it to work right. Okay, so hopefully this was interesting and hopefully it made some sense. We're going to work more on this over the next couple weeks, and so that you'll be set up to use it on your project.